In this video, we are going to solve 3 practice problems using the universal gravitation equation. I would recommend that before I start going over each question, you pause the video and first try to solve it on your own. Only after you think you've solved the question, or if you get stuck and don't know how to continue, then press play and watch the worked out answer. Once again, there are going to be 3 questions in this video, so I'd recommend you pause after viewing each question, but before the answers are worked out. In question number 1, 2 students are sitting 1.50 meters apart. One student has a mass of 70.0 kilograms and the other has a mass of 52.0 kilograms. The question asks, what is the gravitational force between them? Our first step should be to identify and record the known values given to us in the problem. The next step is to identify what variable the question is asking us to solve for that is not already known. As given to us in the problem, the distance d is equal to 1.50 meters. The m1, or mass of the first object, is 70.0 kilograms. Our m2, or mass of the second object, is 52.0 kilograms. And the unknown variable in which we're solving for is the gravitational force, also known as F sub g. Our next step is to determine which equation to use to solve for the unknown variable. Since the question asks us what is the gravitational force, we know we can use the gravitational force equation of F sub g equals the universal gravitational constant times the mass of the first object times the mass of the second object divided by the distance between them squared. Now that we have our equation, we'll plug in the values for our variables. The universal gravitational constant, capital G, is always equal to 6.67 times 10 to the negative 11. This will be the same regardless of the problem. The mass of the first object is 70.0 kilograms. The mass of the second object is 52.0 kilograms. Be sure to wrap the values in the numerator with parentheses in order to prevent any issues with your order of operations. The multiplication should always be complete before the division occurs. This value will be divided by 1.50 meters squared. Be sure to always practice putting these values into your calculator and make sure that you get the same value that I do once the question is over. Your calculator responds to exactly what you do to it. So inputting these values correctly in your calculator is a skill that you need to practice in order to make sure that even though you're setting up the problem correctly, you're still calculating it in the correct order to get the correct answer. Since our answer is a value that is much smaller than 1 and that contains a number of zeros after the decimal, we'll convert that number into scientific notation by counting how many places we need to move the decimal to the right before we get an integer followed by that decimal. The number of times we move that decimal will be equal to the negative power that the 10 is raised to in the scientific notation. Our final answer is 1.08 times 10 to the negative 7 newtons. Let's now look at the second problem. Once again, I'd recommend that you pause the video here and try to solve the problem on your own first, and then resume the video once you've found the answer or once you get stuck and need help. Question number 2 states the gravitational force between 2 objects that are 0.21 meters apart is 3.2 times 10 to the negative 6 newtons. If the mass of one object is 55 kilograms, what is the mass of the other object? Once again, we'll begin by identifying the variables given to us in the problem. The distance is given to us as 0.21 meters. The gravitational force is given as 3.2 times 10 to the negative 6 newtons. The mass of the first object is 55 kilograms. The mass of the second object is what we're solving for. Now that we've identified our knowns and unknowns, we must determine which equation we need to use to solve for our unknown value. We know that the force of gravity is equal to the gravitational constant multiplied by the mass of the first object times the mass of the second object divided by distance squared. We'll have to rearrange this equation to get the mass of the second object by itself. We'll do this by first removing distance squared from the denominator by multiplying it on both sides. This gives us the force of gravity times distance squared is equal to the gravitational constant times the mass of the first object times the mass of the second object. We'll then move the other two variables over to get the mass of the second object by itself by dividing both sides by the gravitational constant and the mass of the first object. This gives us our final equation of the mass of the second object is equal to the force of gravity times distance squared divided by the gravitational constant multiplied by the mass of the first object. Be sure that when you plug this into your calculator, you wrap both sides in parentheses in order to make sure the multiplication occurs before the division. Next, we'll plug in our values as shown in the problem. The force of gravity is 3.2 times 10 to the negative 6 newtons. The distance is 0.21 meters, which is squared in the problem. We'll then divide this by the gravitational constant, which we know is always 6.67 times 10 to the negative 11. And this will be multiplied by the mass of the first object, which is 55 kilograms. Once again, make sure you practice putting these values into your calculator. Check that you get the same answer that I do at the end of the problem. If you do not, check to make sure your order of operations are correct. As stated earlier, the multiplication always needs to happen before the division occurs. Once finished, you'll see that the answer is 38.468 kilograms. However, we'll round this value to just 38 kilograms based on the number of significant digits in our original problem. Our last question says, if two objects, each with a mass of 200 kilograms, produce a gravitational force between them of 3.7 times 10 to the negative 6 newtons, what is the distance between them? Let's again begin by identifying our known and unknown variables. We know that the mass of both objects is each 200 kilograms. We'll label M1 and M2 each with these values. We also know the gravitational force between these two objects is 3.7 times 10 to the negative 6 newtons. We're solving for the distance between these two objects. Our next step is to determine which equation to use. We know that the force of gravity is equal to the gravitational constant times the mass of each object divided by distance squared. We can rearrange this equation by moving distance from the denominator by multiplying it by both sides. Excuse me. This gives us the force of gravity times the distance squared is equal to the universal gravitational constant times the mass of the first object times the mass of the second object. We can then move the force of gravity to the other side by dividing it on both sides. This gives us the distance squared is equal to the gravitational constant times the mass of the first object times the mass of the second object divided by the force of gravity. However, we're not solving for the square of the distance, we just want the distance by itself. So we'll have to remove the square by square rooting the other side. This gives us the final equation of distance is equal to the square root of the universal gravitational constant times the mass of the first object times the mass of the second object divided by the force of gravity. Now that we have our equation, we could plug in our values. We know the distance is equal to the square root of the universal gravitational constant, which is 6.67 times 10 to the negative 11. We'll multiply this by the mass of each object, which is each 200 kilograms in this problem. We'll make sure to wrap our numerator in parentheses so that the multiplication occurs before the division. Be sure that you're square rooting the entire fraction and not just the numerator. Excuse me. We'll then divide this by the force of gravity, 3.7 times 10 to the negative 6 newtons. As always, practice putting this in your calculator, especially with the square root. It can be tricky, which is adding another operation on top of the division and the multiplication that is already occurring. And we get our answer for distance, 0.849 meters. Say goodbye, Rocket. Thanks for all your help.